Hey, hey.
Oh, hello there.
Yeah, scrobbling.
Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hi, I'm Elliot Williams. I'm managing editor of Hackaday.
Today on episode 10, we have XKCD graphs, Turing-complete metacomputers, false fingerprinting 3D printers, and astrictive robotic prehension. And as always, we're going to be walking through some newsy stuff, our favorite hacks from the week. We'll rattle off some quick hacks, and we'll close with the articles you can't miss.
Absolutely.
So, Elliot, I got to start off by talking about last week's show, because when we recorded it, I had not heard any of the, what do you call it, tape footage? What do you call it these days?
Yeah, exactly.
Any of the audio recordings, that you had made at Make Munich. And I got to say, I was amazed. That was an incredible segment.
Yeah, that was super fun to make. I won't even admit how many hours I spent cutting, slicing, and dicing and wiggling around little sound samples to make that work.
Yeah, so if you haven't heard it yet, go back and listen to episode 9, and it's 43 minutes and 30 seconds into it. Elliot went to attend Make Munich in Munich, Germany, and didn't just record interviews with people, but recorded the experience. So you can hear what's going on in the background. Elliot, I assume you were, after the fact, were doing overdubbing?
Yeah, exactly. I interviewed everyone, but I was talking to people in German, so that was no fun for the audience. And actually going back and listening to my German, I have a horrible American accent. It's just not cool. So my interviews weren't going to work. So I had to do an overdub late on Thursday night.
So you can hear your own American accent in your German?
Oh, it's absolutely horrible. Yeah.
That's interesting. I don't speak another language, so I have no idea what... to me, it sounds like it'd be very difficult to hear an accent in a second language.
Yeah, no, it's awful. I sound like a total American.
All right. I'll give you a pass because I don't know the difference. Your suggestion was that I try and do this when I'm in China next week. And I don't think just anybody can do this. Like, how do you go about putting together a piece like that?
I mean, I knew I was going to need some background sounds, so I just walked around a bunch. I tried to just walk around with a microphone and listen to anything that sounded interesting. Frankly, most of it ended up not being interesting. So the only reason, the reason that that's 8 minutes instead of an hour and a half, which is probably how much time I had on the tape, is that I only picked the good parts. It was awesome, though, because I was just walking around, and then all of a sudden this guy started playing synthesizer. This home-built, stick-it-together, like breadboard synthesizer type thing right next to me while I'm walking around with a microphone out. And I'm like, well, that was easy.
Yeah, it makes a nice little soundscape because then you must have written a narrative that you read as the overdub, and I think it worked really well. So congratulations. Good job.
Yeah, thanks. It was super fun to make.
A little bit earlier this week, we published a new paper in the Hackaday Journal, whose full name is the Hackaday Journal of What You Don't Know. This is a wonderful piece that you should go and take a look at on MEMS accelerometers and finding the absolute position accuracy of these. I really enjoyed the work of the authors on this, Gregory Tomasz and Chris Weiner. We were moving to publication with the paper, and Ted Yupao, with his paper, which was the first one in the journal, did a really nice job of using an existing 2-column LaTeX. Is that how you say it?
Yeah, exactly.
A nice 2-column LaTeX template. And looking at this paper, we were about ready to publish, and I thought, this is a single column. It's all kind of different style, and to tie the journal together, it's nice to have it all in one style. And I mistakenly thought to myself, how long could it take to lay it out?
Welcome to typesetting.
Yeah, the first thing I found out is you have to have the full LaTeX Live -full package on Linux, which is like 2 or 3 gigabytes. And then I ended up filling up my root partition while I was installing that. So I had to move my KiCad libraries to a different partition, and then it filled up again, and I ended up uninstalling CUDA. And I looked around for the size that your root partition is supposed to be the last time I set up a computer, and they said 28 gigs was plenty, and they were wrong. But there's all kinds of gotchas there when you're using LaTeX. There is the fact that none of the tildes showed up because it's a special character. I got a bunch of math errors because every time you do an underscore, you have to escape it. Trying to figure out how to lay out the floats for the images and diagrams was interesting. But on the other hand, I really do like the way that it forward and backlinks when you're making references. So that's cool. Also new this week is a column that Dan Maloney is starting called the $50 Ham, which I've not done my ham license yet. Are you a ham, Elliot?
I think, Mike, you're the only person on Hackaday staff who doesn't have a ham license.
I almost did it at Hope last summer. There's a lot of conferences I go to where they're doing the tests, but I'm usually trying to attend talks and meet people and write coverage, so I still haven't done it yet. But Dan has his ham. He wrote kind of a sad story about not being able to find the hobby that really suited him within ham, but he's back on the horse and he's looking and he's trying to do it on a budget. So he's going to be building a bunch of projects. Each of them are going to be under $50. And there was a great conversation in the comments on this article. So I'd encourage you to go check that out. It seems like a lot of people are in the same place. I have my license. I don't know what to do with it. Help me on this. And a lot of good suggestions on the kinds of cool hardware projects you can build on a budget.
And I think that's the right thing to do if you're not into talking to people particularly. Dan actually wrote a column about this a while ago where he's like, I hate talking to people, but I like radio and I like building radios.
Yeah, and people want to build stuff. I mean, there was a cool project out this week. It was written up on Hackaday called Old Meets New in 3D Printed Telegraph, and it's just nothing more than a telegraph key, but it's done with some 3D printed parts. It's put on a wood base, and it all comes out looking really nice. And I think to myself, that is kind of an on-ramp for people that look at ham as kind of an older technology thing. It doesn't have to be.
Yeah, that's a beautiful little project. I like that a lot. When I was a kid, I made a telegraph out of some book that was even older. It was like my dad's book. It was Things a Boy Can Do with Electricity. And they had a telegraph model in there where you used like a busted hacksaw blade as the thing that goes up and down and clicks. It was awesome. I was inspired by an article of ours called Look Ma No Glue Electrostatic Adhesion as If by Magic. The hack's by Jan Henrik Hemsing. And basically it's put high voltage on some intertwined fingers and it'll make stuff stick. And I'm like, hey, I have a crazy high voltage power supply that I ordered for $4 from China and some aluminum metal tape. I'll try to lay this out and do it. And the answer is I didn't shock myself very badly, but I couldn't get stuff sticking either. So I think instead I'm going to have to follow his PCB layout. But just in case anyone out there is wondering if you want to do this, yes, but be careful. You'll get a nasty shock if you get your finger in between the plates.
If you go to the doctor, they will show you a diagram of happy faces and sad faces and the spectrum in between, and you have to point to which one shows your pain. I think we need one
it wasn't
for the
so
level
bad.
of shock.
I was only making I was only pain face number 4 or something. It wasn't pain face 7. It wasn't that bad. But it did feel like somebody put a needle in my finger. There's some stuff about dielectrics there, and I think my trying it first with live electrodes and nothing dielectric covering them up was what caused the accident. Anyway, my next experiment will be probably with a better, less janky high voltage power supply and maybe even the right circuit board. But digging around in this, I found a new word to me, Mike.
A new word? You have a huge vocabulary. How could that be possible?
This is a brand new word. And so I'm introducing a new feature, which is called Fancy Jargon Quiz. The word for the day is astrictive robotic prehension.
I've definitely heard of robotic before.
Yeah, me too.
Astrictive robotic prehension.
This was on a Wikipedia page.
Astrictive. I'm going to say it restricts only in one direction.
It doesn't strict at all.
It doesn't strict at all. Yeah, it's anti-striction.
Yep, good. No, you're totally good. That's good.
Prehension. I'm going to say an inkling to move in one direction or the other.
Oh, what do you know that's prehensile?
Oh, a tail. Yeah, you can grab stuff with a prehensile tail.
Oh, go. You got it. You're most of the way there.
Yeah, it's a robot that can't grab things.
It's a robot that grabs things, but not by grabbing them. It's a
Oh,
robot
yeah,
that
of course.
picks things up, but not by grabbing them. And this is what they use this electrostatic adhesion for in industrial robots, is astrictive robotic prehension.
Oh, interesting. So if you have like a pallet of sheet goods, like paperboard, they might be able to pick that up with electricity rather than suction.
Exactly. They have a roller with a bunch of high voltage fingers on it, and they roll it over it, and it picks up the first sheet just by electrostaticking it.
Yeah, you better put that link in the show notes to make sure you're not just making it up.
Astrictive robotic prehension. I had to read it 6 times.
Yeah, since we're way off on this one anyway, I want to go even further. This makes me think of the high voltage operation at the SuperCon last year.
Oh, yeah, that was awesome.
We
I
really need
didn't
to figure
play
out who
it,
brought
though.
that and get them to tell us. I didn't play it either, too. I'm scared of that stuff. I'm like, I
I
like to be able
saw-
to use my hands.
I saw what was going on, and I did not play it.
Yeah, really. I think we talked about it on the year in review, but somebody brought along the game of operation and made it so you wrap a wire around your wrist and you use a metal tweezer to pick the plastic parts out. And if you touch the edge, you get a very large shock, large enough to make you throw the tweezer.
Yeah, instead of it going buzz, you get 3,000 volts. Hee hee.
Yeah, and I always wondered how dangerous the circuit inside of that was. So I'll tell you, I am very glad today that I know about astrictive robotic prehension.
Oh, like a pro, you said that. That was beautiful.
All right, to close out our news section, I am headed to China next week. It is going to be a ton of fun. Electronica China is happening in Shanghai, and Sophie Kravitz and I are going to be at the Bomb to Buy booth on Wednesday the 20th, I think around 2 p.m. for several hours that afternoon. If you happen to be in Shanghai at Electronica, stop by. We'd love to see you. We are then going to Shenzhen for the end of that week and doing a meetup at X Factory with Seed Studios. This is Friday the 22nd of March. And finally, I'll be headed to Vietnam to meet up with Sean Boyce and doing a meetup on Sunday, March 24th in Ho Chi Minh City. So lots of stuff coming up. And of course, I'll be recording as much as I can for the podcast and writing about it on Hackaday.
That sounds like it's going to be super fun.
All right, so adventures there. Watch Hackaday for news on that stuff. And I guess next week we'll have, I think Tom's going to host with you.
Yeah, me and Tom Nardi will hold down the fort while you're gone, and we'll take whatever audio bits you send us and cook them up into a pleasant audio soup.
Nice. All right, let's jump into hacks, Elliot. What do you have this week on your list of favorite hacks?
Let's see. My first favorite hack this week is 12 channels of LEDs give RRR GG BBBB light. I might have gotten that right.
I think you're supposed to pronounce it.
Rrrgababa. I'm going with AJM to pronounce this hacker name. I think AJM saw a bunch of awesome LEDs on DigiKey and decided that he would not just order one color, but the entire spectrum of them. So the hack is 12 medium high, I think they're 1 watt LEDs, and then a bunch of fiber optics to combine them together into a single beam. And why would you want to do this? Well, if you've never seen RGB, but with lots more R's, G's, and B's in it, you don't know what you're missing. You might think that you can cover the full spectrum with just 3 colors, and we're often told that you can. But there's actually a ton that's visible and outside of that, for which you need a couple more funny colors. Like it's good to have a cyan, and it's good to have a green that's more of an emerald green than a green, and other stuff like that. So I don't know. People tried to make up reasonable reasons to make this device, but I don't think they need one. I think it's just going to be beautiful.
Yeah, I don't think you finished describing though. So it takes each of these bulbs of a different wavelength and it puts them through fiber optics into a optical combiner block, and then you get a single fiber optic out the other side of that.
Right, exactly. He cut a little trapezoidal shaped thing because if you look at the cross section of the 12 different tubes going in and the smaller cross section of the one tube going out, he needed to basically make a light funnel. And so he's got a little trapezoid of acrylic that necks down, and there's a lot of polishing to make sure there's no stray reflections here. But it's a really cool project.
Yeah, this is one of those that I really wish I could see in person.
Yeah, I wrote in the comments pics or it didn't happen, but because
well,
there's no way to take a picture of it.
Right.
If you have a camera that has an RGB sensor, you can't take a picture of it.
Well, I think, sometimes you look at blue LEDs and they look out of focus, and that's the wavelength of the light.
Yeah, they're just too blue.
Yeah, and you're not going to get that from a photo. You just don't get that same effect. So on this, I'd really like to look at it and see if my eye can actually pick up, am I an ocular file or not?
You absolutely will be able to. And the one place I've come in contact with this live is actually laser shows. Laser show people used to always have this problem that especially with the blue is just too blue, right? It's like the blue LEDs. And so their old trick is to mix in a cyan and this funny extra green. And if you've ever looked at the standard color diagram, it's this kind of thing that's almost basically like a guitar pick shape or something. And then if you pinpoint the red, the blue, and the green in there, it gives you a little triangle that's on the inside. And you can kind of get a feeling from looking at that printed out, if it's printed out on nice paper with good pigment. You can kind of get a feeling of the colors that you can't generate using RGB.
Yeah.
The stuff outside the triangle. I've seen outside the triangle, man. Anyway, this is a fun project because it makes that accessible for you, and he can experiment with it. And he's got a really nice smartphone interface to it with sliders, so he can dial up more, nearly ultraviolet, and he can dial in less of this. And it looks like a heck of a lot of fun. So what do you got?
All right, the first one on my favorite hacks list this week is an article written by Brian Cockfield called "A Nurse Call System Becomes Turing Complete." So you've been to the hospital and you see the beds that have those handheld, I think they can change the TV, but there's also a picture of nursing staff on there. And if you click it, the nurse will get an alert and come to your room. Are you familiar with these?
Yeah, exactly.
So this person named Eric De Jong works professionally with these systems and was getting some in-company training on how the messages are relayed back and forth, and started to realize that he might be able to build a Turing-complete computer system out of all of the devices that make up the call system. So it's not just the device itself, but it's how the messages are transmitted can become a computer system in themselves. And I think a quote from his motivation really sums this one up. He says, "It struck me that certain routing features might be used for more than just sending text messages to pagers. So I spent some time researching how to turn the Nextrix application into a rudimentary computer system that will execute a program of assembly-style instructions with conditional branching."
Too much time on your hands plus too smart equals trouble.
Oh my God. Oh, it's perfect though. I mean, there's machine instructions for this network of call buttons.
Yeah, that's phenomenal.
Yeah, and it goes really deep into it. I think the thought of what is Turing complete and what actually makes up a computer is one that people are kind of familiar with. But then when you read through this, you really start to get the feeling of what a meta computer is. And of course, I'm going to mention this on the show every single week. One of my biggest introductions to these computing systems was The Diamond Age by Neil Stephenson, where this fairy tale book goes through all of these different real life scenarios where a Turing complete system can be built. And here's one in real life. So I'm delighted by it.
Did he make a compiler for it? Or does he have to write in the nurse call system's assembly language?
No, I think it's a virtualized system. So Once he figured out that it was possible, he put together basically a proof of concept that doesn't actually run on the system.
Oh, right, because that would be
Yeah, I think your
dangerous and
employer might look.
irresponsible.
Yeah,
Darn it. Fair enough. Fair
I'm
enough.
sorry, I can't call the nurse right now. I'm computing pi.
Exactly. Yeah. Okay. I guess I buy it. Let's see. I saw another enchanting one. This week my hack list is full of enchanting hacks. This was omni-wheels move this CNC plotter. The hacker's handle is Linjib, and this is basically an omni-wheel robot. It's a 4-wheeled robot. If you haven't seen omni-wheels, they're wheels, but the gimmick is that they have little rollers on them 90 degrees to the way you would think of a wheel's treads normally being. So they're like sideways. And what this lets you do is you turn one pair one way and the other pair the other way, and the thing scoots in basically any direction, right? It can move in any direction depending on how you turn the wheels in combination, whether they roll in the direction it looks like they should or whether they roll perpendicular to that. And as a proof of concept, I put a marker on it and used it to draw stuff on paper.
Yeah, it's dead reckoning along the way. And so when it comes to going back over parts of the drawing, it gets a little bit off. But I'm fine with that. I really love this idea of testing out a robot as a plotter because you end up with something when you're done with it, which is a lot more than just seeing a robot drive around the room and going, huh, neat. And then you don't have to get into the problems of, am I maze finding? Do I know how close I am to a wall? All of these much more difficult problems can come later.
Making a plotter is the kind of thing you can only do with omni-wheels because they're the only robots that can, turn on a dime, can turn that really sharp right angle corner. And so if you had a robot that was shaped like a car, it would have to turn these big radiuses, and that's no fun. You can't make a plotter out of that.
I hadn't really thought about that aspect of it, but you're right.
So it uses the one unique feature of an omni-wheel bot, which is they can stop moving forward and instantly start moving sideways. Just, it's a great proof of concept demo of that functionality.
Nice job, Linjib.
Oh, one last thing I need to say about it. Sorry. This was a great project because it was done on, a budget of about $100, I think. Most of which was spent on the wheels. If you have a 3D printer, you can print omni wheels, and there's tons of designs out there, and you can cut the price of experimenting around with omni wheel bots down to virtually nothing if you've got a few stepper motors or even continuous rotation modified servo motors kicking around and can print some omni wheels to slap on them. You are 90% of the way to this project with very little outlay. Plug for 3D printing.
So I also had one that was an interesting mechanism this week by one of my favorite hackers in the world, Matthias Wandel, who you probably know from woodgears.ca. And this is a Valentine's project that I somehow missed. I think it came out, I don't know, at the end of January. But I'm glad that Donald Papp picked it up and wrote a feature on it this week. It is a pantograph made of Legos for engraving chocolates. So if you don't know what a pantograph is, it is a 4-bar linkage that is used usually to reduce, but it can also enlarge the movements of the operator. So you're going to have a stylus that you will trace over a pattern, and elsewhere on the 4-bar linkage, a cutter head or a plotter, whatever is being used, will draw that same pattern, but either smaller or larger. And in this case, it's much smaller. I really am delighted by this one because he did things like made the stylus by putting his Lego part into a pencil sharpener in order to bring it to a point, which is delightful. Early on in his video on it, I was looking at the product and I was thinking, ooh, that looks really poor. It's not a very good cut. And as soon as I was thinking that, he narrates that the cut is not very good and he's going to try and freeze the chocolate because he thinks colder chocolate will make a better cut. And that indeed is what happens.
Nice.
Then at some point he says that past experiences showed him that Lego parts can wear out. And so this has a spinning cutter head. It's being driven by a Lego motor and it's geared down. And he takes mineral oil and puts it onto the bearing surfaces for this. And of course, makes the point that it's fine to use mineral oil, and this mineral oil is a food grade product that is used for as a laxative.
I was going to say.
Says that he hopes that it doesn't get much on the chocolate, which I'm sure it didn't. But there's like those brilliant tips that transcend the project itself are there. And then he uses a bandsaw to cut the chocolate, which I'd be more worried about the food safeness of the bandsaw than I would the lubricant. And finally polishes the cut surfaces with a little blast from the heat gun, which I think is a good chocolatier's trick.
Yeah, I need to look into chocolate as a medium. I've been just eating the stuff instead of putting it in the vise and carving at it and take a rooter to it. That's mental. Who loves 3D printers? Elliot loves 3D printers. Let's talk about OpenSCAD gives you parametric boxes. It's a beautiful library of simple project boxes in OpenSCAD that you can custom size to however you need them, print them out yourself, and you're done. And I've always said that project boxes is one of the killer apps of 3D printing. If you try to go buy them at the store, they're always in the wrong shape and size, and they're always too expensive. Instead, you can just be like, hey, my project is a rat's nest and a horrible piece of perf board. I want to hide this and mount my LED somewhere. Bam, 3D print it. So this is the code that will let you just type in the numbers of the size you want and hit enter, and boom, it comes out your 3D printer. The nice things about this library in particular is that it's got a hinge library in there, so you can make hinged boxes, which is a little bit of fiddly work with OpenSCAD, and it's also got clasps, so you can make a lid that closes and hooks closed.
I think it's multiple options, so you can do a clasp, you can do a screw closure, or you can do a magnetic closure.
Yeah, you can do whatever you want. Making magnetic closures is dead easy. You just put holes in there and stick magnets in them later. Making hasps and stuff like that is hard and requires some work. So it's really nice that someone else has done the work for you.
Yeah, go through, make sure you click through to this one and look at the examples because they're really quite visually stunning and they've printed off a ton of them.
Again, I can't overstate the ability to not have to buy standoffs, not have to cut Altoids boxes, because cutting metal is no good. Not having to saw things that don't ever fit exactly right. This is just pull out your calipers, measure, type, print, done.
Yeah, so there's a lot of OpenSCAD or OpenSCAD lovers out there. Did you see this comment from Duncan Bell on this article that he spent the time to develop a Excel front end for OpenSCAD?
Oh, dude, that was crazy.
Yeah, so he started a project on Hackaday.io, but there's no code up there. So I need to ping him and say, put it up there. We all want to see it. But the pictures and the animation are pretty awesome.
Yeah, I mean, the neat thing about OpenSCAD as a CAD program is that it's secretly a programming language. Mm-hmm. And so you can make preprocessors that kind of auto-generate code for that. There's a PySCAD, I think it's called, is basically an OpenSCAD preprocessor language in Python that is kind of object-oriented and generates nice code. So again, it's this higher level on top of it that makes this meta generation of your 3D models even easier.
Yeah, and Brian Benchoff did that series, how to make a part in anything, and OpenSCAD is one of those. So why don't we put the link to that? If you haven't played with OpenSCAD, go and play with it. It's a ton of fun.
For sure.
All right, I'm ending up with a really old project that was new to me. I submitted it to the tips line, and Ted picked it up, and I didn't realize that he had used it in his talk from SuperCon in November. So I'm really glad he picked this up. This article is called "Make XKCD Style Plots from Python." So anyone that follows the very popular Geek Chic comic series called XKCD knows that there's a very specific hand-drawn style to the graphs and the data presentation. I look at things like this. I look at talks where the slides are hand drawn, and I have horrible handwriting. I can't draw these things. I'm always very impressed. I wish that I could do it. And I'm not the only one. A person named Jake Vanderplas came along in 2012 and figured out how to make an XKCD plot generator in a program called matplotlib, which is a Python script. Elliot was just talking about a CAD language where it was secretly a programming language. This is one where it's just a bit of simple code, and out the other end you get these hand-drawn graphs that are epic.
I know it works in Matplot or in MATLAB and in Matplotlib for Python both too. So no matter how you like to do your numerical analysis and plotting, you can make XKCD style comic strip style plots out of your super serious data.
Yeah, that is one thing that Ted pointed out, is you have to watch out because this kind of calls into question the seriousness of what you're trying to present.
Yeah, and I think the one place where it's super useful is that it exactly does that. So if you've got data where you don't have a mazillion samples, you've got 10 samples, and you're just fitting a line to it to kind of illustrate, you just want to show a simple trend and you don't have much more data to support it than that, you can draw a fancy line, or you can be like all these web dev people who fit, nth degree polynomials to it. Or you can make it look like a cartoon comic strip, make it look like you drew it by hand, which is probably about all the validity there is in the data anyway. So I think it actually has a really useful function for kind of conveying this is a napkin style representation of the data I've got if you've only got napkin style data.
Yeah, now that I know about this, I'm on the hunt for good applications. So hopefully you'll see more of this in the future. All right, it's once again time for quick hacks.
Quick hacks.
Someone called me out on the sound effects last week.
Really? Awesome.
Yeah, I went back and looked at the comments from the thing. We should probably ask Rich if he has any inspiration to write some interim music for these. It feels like maybe we should have a little transition music. I think what we need to do is compose some music on our badges, have that play.
Oh, that would be awesome.
Yeah.
All right, I'm willing to do that.
All right, why don't we start with your quick hacks list, Elliot?
So yeah, I got 3 quick hacks this week. I'll start off with miniature 3D printed forklift is quite palatable. A bull. Yeah. By the hacker's name is Leon. It's a video basically of him making what ends up being a remote controlled forklift that actually lifts things up and tips forward to drop them. It's really cute. You should also check out his channel for his other builds. He used a CNC machine to build this forklift that he quite obviously built himself. And so I was like, I'll dig into his channel. His CNC machine is what you should really be looking at. It is awesome and self-built. So check out that guy's video channel. You can get to it by going through miniature 3D printed forklift. Beautiful stuff. Coming up next, speaking of CNCs, was creating lenses on cheap CNC machines by Brown's CNC. And this was really cool because it's taking a regular old Cartesian XYZ CNC machine and making lenses which are kind of intrinsically round and want to be done on a lathe. He got enough resolution that he could make, working magnifying lenses there. The comments for this one are phenomenal. You should read through. People who have experience with actual lens grinding CNC lathes chime in. People who've done similar things on CNC machines. And then people who've made lenses out of molds all get together and give you 3 or 4 different options for making lenses yourself, custom lenses out of acrylic for yourself. So great comments, great article. And last but not least, or actually totally least, last and least is Brian Benchoff's finally an open source calculator with tongue fully planted in cheek. Microsoft open sourced their calculator application, and who cares? And I think that's the point. I think this is Microsoft is trying to make themselves a better contributor to the open source community. I'm old enough to be a veteran of the Linux versus Microsoft wars, and frankly, Open has won and Microsoft has lost, and they're trying to open everything up to us now. But they still don't get it. And so they're like, here's our calculator application from Windows 95. No, I think that's too snarky. I think actually it's a fantastic tutorial example of a very simple GUI program. So if you want to code for the Windows platform using their native APIs, it's actually totally worth looking at. There's also some numerical bugs it's had that you can now go in and fix after all these years. And the secret Easter egg is that you can now disable the send telemetry flag and stop calling home with your calculator app.
All right. On that note, let's move on to my quick hacks. I have 3 amazing hacks this week. The first one is called Speedrunning Windows 95. I'm a huge fan of watching speedruns. And actually, I'm a huge fan of watching AI trying to do speedruns as well. But I have not done any of those myself because I just don't have the skills to compete with the top people. And again, I'm not the only one. In this case, a person named Oscar Eczek came up with the idea of speedrunning the Windows 95 setup process. Like installing Windows is the speedrun in this one. So it's running inside of a virtual machine. There is the current record is now just 1 minute and 10.9 seconds. And you get to see things like them putting in the product key and deselecting almost all of the components in order to make it install faster. And it's pointless, and people are taking it seriously. 2 things that go well together. All right, my second quick hack this week is a no-cost heavy metal lathe from Junkyard Parts. And this is a serious-looking lathe made of not serious-looking parts. I think most people know if you're going to have a good lathe for machining metal, you're going to have a really heavy base. If you don't know about that, you should definitely go and read Quinn Dunkey's series on choosing and buying your first metal lathe. In this project, Flying K machines used 2 engine blocks, which are machined dead flat in order to make sure you get a good seal on the gaskets, are used for, one of them is upright to hold the headstock, and one of them is flat for the bed where you clamp the parts. The goal here was a 0-cost build, and the verdict isn't in on that, but it's pretty inexpensive, and the image library on this is vast. So you can easily get lost in this one for an afternoon or more. I mean, machinists are the Industrial Revolution's version of blacksmiths, right? That's who you go to get everything that you need produced.
That's right.
Yeah, so awesome project. Look into this one. Probably shouldn't have been a quick hack, but there's only so much time on each show. The final one definitely is a quick hack. It's called Stalking Last FM Streams on Spotify. And I'm glad Lewin's as old as I am and actually remembers when Last FM was a thing and that you would broadcast what you were listening in something called scrobbling. But the point is, I've tried these services, these modern services like Spotify and Pandora and Amazon Music, and they're fine. But if you listen to them a lot, eventually you want to be exposed to new stuff and more variety, and I don't think their algorithm engines match my tastes very well. And so what this project put together by Hexalis is doing is looking at what's being scrobbled by people on Last.fm and automatically generating it in Spotify using their API. So it's just a fun little connector script and an interesting thing to look at if you want to diversify your listening. Finally, we're closing the show today with Can't Miss articles. These are articles written by our wonderful Hackaday contributors. Elliot, what's your can't miss this week?
My can't miss this week is Tom Nardi's No, Your 3D Printer Doesn't Have a Fingerprint. And this is taking apart an academic paper that tries to fingerprint the output, the 3D printed objects that come out of 3D printers, and then attribute them back to the printer itself. And the basic idea is that this is going to be a forensic thing for use in courts, like bullet analysis can tie a bullet casing back to a gun to prove that somebody did something. And they are getting everything 100% of the time right. And if something sounds too good to be true, it probably is.
Yeah, so I think the actual identifying and matching back to the prints is dubious at best. And part of the reason is over time, these machines are going to change. And so if you print an object and then you don't print anything else, and that object in pristine condition is run through this test, then yes, I think you'll be able to correlate it with that machine. But that becomes less and less true with each minute of printing that you're putting through that. You're switching up different materials. You're running at different temperatures and with different print heads, and you're going to have a lot of variation that I would say it multiplies over time.
The big non-X factor here, the big variable that they didn't vary, is switching the filament used on each printer. And I'm actually concerned that what they're doing is they're identifying a particular roll of filament that just happens to have been run through this specific printer rather than something else. And if you've done any 3D printing with PLA, for instance, you know that if you leave it outside, it sucks up water and it gets little bubbles in it. And these kind of bubbles are one of the features they use to identify the printers. If you have a spool of not 100% top quality filament, you know that it's got a lot of periodic width variations in it because the factory that was making the filament will pull on it harder, or their machine's out of true, and it makes the filament thin and then thick and then thin and then thick. And it's this kind of features that they're looking for in the resulting print and attributing back to the printer. But because they don't change filament for any given printer, you never see cross-filament variation. And so I'm not 100% sure they're not just picking up this object came from that roll of filament over there.
For me, one of the examples that they use in this is a legitimate example of where 3D printing is appearing in criminal enterprise, and that is in credit card skimmers. And so there have been instances where 3D printers have been shown to have been used to make the credit card skimmer bezel look like the original ATM bezel. And so in that case, yes, a forensic method of identifying that print or correlating it with what type of printer it came from might be useful. But for several of the others, like 3D printed guns, or they actually mentioned 3D printed hand grenades, and also 3D printed bullet casings.
Yeah.
These are things that just don't exist right now and aren't likely to anytime soon.
That instantly raised all of our hackles, I think. The abstract starts, as 3D printing technology begins to outpace traditional manufacturing, which it isn't, malicious users increasingly have sought to leverage this widely accessible platform to produce unlawful tools for criminal activities, which they don't. Therefore, it is of paramount importance to identify the origin of unlawful 3D printed products using digital forensics. And then they have a picture of a 3D printed hand grenade. The one thing that is true in this, as you pointed out, is the skimmers. All the skimmers I've seen are made using SLA printers, and I'm surprised, again, that they are able to tell the output of one SLA printer from another, because I've seen the results of SLA printers, and they look so smooth and so regular to me.
Tom is basically doing peer review with this article, and I wish that he had actually been one of the peer reviewers on this paper, because I think a lot of his conclusions are founded and fair.
The real problem with this paper, and Tom's article gets into all of the technical nitty-gritty, the one real problem with the identification in this paper is that they take it as given that they have samples of prints made on every printer in the universe. And so the whole identification method is predicated on them finding some shrapnel or a piece of a 3D printed imaginary weapon, and then being able to trace it back to your printer because they already have a pre-existing sample of a 3D print from your printer done on that same filament or with that same material. And that's the part that I think really strains credibility.
All right, so this week, Dan Maloney was onto a great one, which is engineering for the long haul, the NASA way. And his jumping off point for this was the end of Opportunity, the little rover that could on the planet of Mars, that blinked out of existence. And, it was sad. I think a lot of people felt emotional about this robot exploring another planet. But I think anthropomorphizing this robot is not weird, right? It even looks kind of comically like it. You had that movie Wall-E where you had a little robot that was like this. I think it's really easy to assign life to these advanced machines. And the really fascinating thing about this is on spec, Opportunity was supposed to have a mission life of 90 sols, so 90 Martian days, and ended up living 37 times longer than that.
Like you say, the little robot that could.
Right. Yeah. So, and also, there's just so many little nuggets in here that I think are really interesting. So Dan says that there's enough data that came back from Opportunity that it's going to be something like another 15 years before we've exhausted the analytical usefulness of that data, which I think is very interesting. But it's not just an article about the robot. The article is, why does NASA design equipment so ruggedly and so robustly that it does last 37 times longer? And that's a really interesting question.
He ends the article with Voyager.
Yeah.
And the Voyager mission was originally supposed to be significantly shorter. Voyager 1 was to Jupiter and Voyager 2 was to Neptune. And Voyager 2 is just now about to head out of the solar system. And they kept these missions going because they kept getting data back.
Yeah, and the best nugget on that, I'm glad you mentioned this. The RTG power systems, which are basically nuclear batteries, are only going to last about 5 more years on the Voyagers.
Yep.
Now, to me, when you say nuclear battery, I think, oh, that will never stop working. So to think about it dying on this seems weird, but then these launched in 1977.
Did you read? Yeah, did you read his article on plutonium? It's one of these plutonium generators that's making Voyager go. Dan must have an extreme fondness for Voyager.
Oh yeah, and we talked about this before because we featured that plutonium pellet manufacturing process is kind of back online, and here's a good example of what you can get out of those.
Yeah.
I mean, his conclusion is that when you have a mission that is so expensive to get out of Earth's gravity and send it to another part of the solar system, that the added expense of over-engineering your already over-engineered designs is minimal. And so why wouldn't you do it, especially when the scientific windfall is so huge? And he uses several examples of it and talks about NASA's ability to analyze past failures and develop and put in place systems that help prevent those from happening in the future. And it makes me feel really good about the engineering world and how we can work together to build on each other's successes.
Yeah, the one bit of insight in there that I thought was maybe a tiny bit cynical, but probably also really worth having, is that they have to engineer these things to 100% work through their science life. And so they've got a bunch of science they want to get done on this, and it has a certain amount of time, and they want to be 100% sure that they can get all of this basic level of science done, and then anything else after that is gravy. Part of what appears to be these things living longer than their life is that the life they're spec'd at is this kind of minimum, here's all the science we really want to get done, and here's how much time we've got to do it spec, which kind of limits scope creep, and it prevents you from throwing every possible device on the thing. We've only got 90 days, 90 Martian days. That's it, folks. And then allow for anything after that to be gravy. And they do contingency planning for it. What if it lasts 1 year? What if it lasts 2 years? What if I don't think they'd planned what if it lasts 13 years or however long Opportunity's been up there.
You know, it makes me think of a talk that I was at by someone who was working at Planet Labs, who does cube satellite arrays for imaging the Earth. And they're mentioning that they were not using rad hardened equipment. They were using cell phone grade equipment, and their cost curves were looking to have a certain percentage of failure. And if they didn't have that percentage of failure, they saw it as wasted money because they were already planning to replace that equipment. And it's a really interesting way to look at reducing the cost of really hard engineering problems. But that's that's low Earth orbit, right?
Right.
And so you're sending, these things that are the size of a box of tissue up in a spaceship and then having them orient themselves into swarms of 20 of these little satellites. And then, you have your useful mission of, I have no idea, 9 months, a year or something like that. And then you replace them again. But how many times have we actually landed hardware on Mars or sent a probe past any of the outer planets? It's so incredibly rare to do these things. And it feels like as soon as they're out of your grasp, as soon as you hit go on that rocket, you just have to do with what was on board. Although they do some amazing things in repurposing equipment through software updates and tweaks.
Yeah, exactly. That's the other part of this, is that they do tremendously creative things to keep these missions going. If they lose this function, they figure out a workaround. And if it loses that function, they figure out a workaround. And so some of it's just, human ingenuity.
I think obviously right now we're seeing a renaissance in all the space engineering. And so it's great to see articles like this that kind of look back and see what's accomplished, because it allows us to look forward. Recently we saw that these CubeSats were sent to Mars in order to help relay the signals as the newest lander there touched down. And there's a lot of news coming out about weird moon orbits and having humans be more closely linked to lunar travel. And I think we're just going to see a lot more really amazing stories come out of what people can do with the technology at hand.
And before we go, I'd like to give a shout out to MK, who found the Easter egg in episode 3 and posted it in the show notes. Go check that out if you're interested, and see if you can figure it out yourself.
All right, so with that, the Hackaday podcast is drawn to a close. As always, we'd love to hear from you. You can leave comments on the show notes, which you'll find at hackaday.com/podcast, or you can email editor@hackaday.com. Until next week,
keep on hacking. 8-bit stingers.
I definitely scrabbled.
Yeah, so for quick hacks, what I've got is a second take.